So we got an interesting result from NASA, specifically James Webb Telescope, about a planet that is not too far away from us, around 40 light years away, which is really close. And one fascinating thing about this planet, when you look at the illustration, is like, this looks like Jupiter, but really red. And I can see the red spot that highlight, of course, maybe most likely a lot of huge storm happening around that particular region. People call it a really great tornado, but really fascinating to see with the data that is collected from James Webb Telescope about the contents of this particular planet's atmosphere. This planet is known as VHS. Kind of reminds me of the cassette that we used to use to watch movies. But anyways, 1256b, and you might recognize this as one of those exoplanets we call it. Most importantly, it is known to be orbiting two stars, and the amount of distance from it to the star is pretty much 4 times the distance from Pluto to its sun. And this is really a fantastic spot for astronomers to be able to dive really deep into this particular exoplanet, because of course it has a lot of rich atmospheric conditions which varies from water to that of carbon dioxide, carbon monoxide, and interestingly enough, we have silicate. And you might be wondering, why is silicate such a big deal here? It is noticed that due to the low gravity of this planet, these silicates tend to suspend really high, because of course the silicates do have two types. One is the final and the other ones are really heavier ones. So the final ones, they tend to suspend really high, which are really fascinating for astronomers to understand more about how that impacts the various conditions in this planet. Furthermore, when looking at other things about this planet like mass, but also other detectable things that might be helpful for astronomers to dive into, here are some fascinating results to keep in mind about VHS 1256b. Now, according to this article, it says there that the atmosphere of this planet changes from rising to mixing to moving frequently around a 22-hour day run, which is really fascinating in terms of bringing hotter air really up and pushing down colder air. And this mixture really highlights how vibrant and energetic, let's put it that way, the atmosphere of this planet. And this is an addition to how gravity plays a role in this particular planet. We'll talk about that in details. Furthermore, looking at how this planet here is focusing mainly on how its atmosphere is based on temperature coming from the suns, you might think that, hey, maybe the two stars will really shine a lot of light on this particular planet. But because of how far, around 10,000 years distance period, it is kind of fascinating to see that the light of the star doesn't make any impact in terms of, or doesn't contribute to the planet's light. Therefore, this really makes astronomers to see that this is indeed a really target region, in such a way that the silicates, when they suspend higher up in the clouds, it actually creates a temperature of this planet to be around, guess how much? 830 degrees Celsius, which is, in conversion to Fahrenheit, is 1500 degrees Fahrenheit. That is really boiling region levels. No, melting region values, if you think about that. Now, looking at the two types of silicates that was highlighted at the beginning of this video, it says here that the larger silicates tend to be really hotter than that of the lighter fine silicates. And this, in addition now to focusing on the gravity, it is highlighted that this planet's gravity is less than the average brown dwarfs that we know, and this contributes heavily to what we understand about the cloud that is made out of silicates, in such a way that this here enables the atmosphere of these to not only be a little bit suspended really higher up around the atmosphere, but also creates that turbulence in this particular atmosphere of the planet. And in addition to that, the age of this planet, when you look at it, is really known to be really young. Like, guess how much young? Like, if you think about Earth, it's around 4 point something billion years, but this one here, how young is around 150 million with the M years old. And so this shows that as time goes on, this atmosphere that is really turbulent to become to cool down over time, and we're going to be seeing that, well, I don't know how many years we're going to see how the temperature is going to drop over time. So really curious to see how this is going to play out in future analysis. Now, looking at details about the description of the spectrum, it says here that a research team led by Brittany Miles of the University of Arizona used two instruments known as spectrographs aboard the James Webb Telescope, one on its near-infrared spectrograph, also known as NIR spec, and another on its mid-infrared instrument, which is MIRI, to observe a vast section of the near to mid-infrared light emitted by the planet VHS 1256b. Now, they plotted the light on the spectrum, identifying signatures of silicate cloud, water, methane, and carbon monoxide. They also found evidence of carbon dioxide. And now, you might be wondering why the choice of these two instruments, the near-infrared and the mid-infrared spectrographs. The reason why is because due to the long distance that this planet is from its star, it is not really possible to use coronagraph or transmit techniques to be able to capture this much rich details about the dynamics based on the content of the atmosphere in this particular planet. Now, the future hopes that analysts are predicting about this planet is based on the atmosphere, that because of how far this planet is from the star, this planet's atmosphere will become cooler, and the silicates that are really creating this much turbulence will subside, and the clouds will become a little bit much more clearer, therefore being able to see more of the topography, hopefully, of the planet. But this is like 1 billion years there from now, so nice to wait for that. All the same, I'm really interested to know your thought about this in the comment section down below about this exoplanet, the content of silicates in the atmosphere, something that is really not seen, and interestingly, based on other telescopes, they've not been able to detect this much detail compared to James Webb Telescope, which is really a great achievement here. But I'm really trying to know your thought about maybe if they put in more different types of telescopes that has different capabilities, would they be able to detect more containing in this atmosphere, or not really at all? And yes, let's see what you have to say in the comment section down below. All the same, thanks for following me through this. See you on the next one. Stay smart as always, and believe in yourselves.